Hey Precal, welcome to Pandemic Education, episode 3. Today we're going to get started on Unit 9, Lesson 2. Let's go. All right, so Unit 9, Lesson 2, Part 1. So I've got a do now up here. I would love for you to pause it and attempt these 1, 2, 3, 4, 5 different problems. When you're ready, resume it and I'll put the answers up. All right, so here are our do now answers. If there are any problems that you had a question about or were unsure of, please make sure you mark it and we can talk about it during office hours. So our objective today, we're just going to focus on solving exponential and logarithmic equations. Next class, we'll talk about finding the inverses of exponential and logarithmic functions. So to start off, I want to ask you, and I just need you to think about this. How do we solve an equation? How can we test a solution once we find the solution to an equation? And then we'll worry about inverses later. So today we are just solving equations, and we're also going to talk a little bit about extraneous solutions. So a quick recap, all of these basic properties of logarithms, hopefully you have them all written down in your notebook. If not, definitely pause it and take a second and write these down. They're important and we're going to need to reference them again later. Okay, I'm going to keep going. Let's talk about our product rule, quotient rule, power rule. Also super important, and we're going to use these specifically to kind of manipulate and solve for variables in our exponential and logarithmic problems. Again, please make sure you've got these 3 rules written down. I believe that you can find them on your formula sheet. So if you have your formula sheet, definitely get it out so you can utilize it today. Okay, and then last but not least, remember our common log is base 10. Whenever we say log, we just mean that the base is 10. Natural logarithm, the base is e, and we use ln for natural log. And e is a real number. We just shorten it up and say natural log instead of log base e. And then last but not least, change of base. We will probably need to use this a little bit today, so should be good. All right, so if we are solving exponential and logarithmic equations, our first step is always going to be to isolate the function that contains the variable. So there's going to be a lot of pieces in our equation, right? And the first thing we need to do is get whatever piece has the variable in it by itself, right? We need to move all terms with similar bases to one side of the equal sign, and terms that do not have a common base need to go to the other side of our equal sign. We can then use properties of logarithms and laws of exponents if we need to condense things and kind of simplify them a little bit. So if we have an exponential function, right, our function is exponential and our variable is up in the exponent, we can use a log on both sides of the equal sign to eliminate the exponential terms. I say both sides because remember, whatever we do to one side of an equation, we have to do to the other. We can't change our function. We can only change how it looks. So applying a log is a way of changing the way a function looks without changing actual values. If we have a logarithmic function, we will raise both sides of the very equal sign to the same power, again, to eliminate that logarithmic term. Use order of operations to continue solving. Remember, we have to, we're trying to isolate a variable, so we're kind of going in that reverse order. We'll add, subtract, then we'll multiply, divide, et cetera, to get our variable all by itself. The last thing we need to do, and this is a big one, please mark it up, start, make sure you write this down in your notes, is that we need to check for extraneous solutions. An extraneous solution is a solution that we get when we're solving that doesn't actually work because it's outside of the domain that we are allowed to have. Our log function will be undefined if whatever we're taking the log of is less than or equal to 0. So if we have an x value that we plug in that creates a 0 inside of that logarithm, it's an extraneous solution, right? It's outside of our possible domain, and so therefore it's not a solution. Exponential functions are defined for all real numbers, so you only need to worry about this with a logarithm. So, all right, we're actually going to try these problems together. Let me get my document camera up and moving. Okay, here we go. So, our first problem, we are going, again, to solve for x with this equation. So, I'm going to do all the little steps. I know that we don't always need all of them, but virtual instruction, you can't tell me what you need and what you don't need. So I'm going to start. I'll draw my line. Here's my x. So I am trying to get that all by itself. So I'm going to start off by adding 8 to both sides. Remember, whatever we do to one side, we have to do to the other. These will cancel. I'm going to bring this whole thing down. 8x equals 32 plus 8 is 40. All right. So now looking at this. This is an exponent, right? I've got a base 8, and I'm taking it to the 8x power. I need to get x out of that power seat. So to do that, I'm going to take the log base 8 of this side. Because if I do that, this 8 right here and this 8, my two bases, the log base and the exponent base, are going to cancel out. Now remember, whatever we do to one side, we have to do the other. So I have to take log base 8 of whatever this is. So my 8x comes down, and I have log base 8 of 40. I like to use parentheses because if we were to actually type this into our calculator, you'll see in a second. The next step we need to do is divide by 8, and we do that on both sides. Those cancel, and I get x equals log base 8 of 40 divided by 8. So I like the parentheses around whatever we're taking the log of, because the log base 8 of 40 is very different than log base 8 of 40 divided by 8. Two different numbers, so make sure that you are very clear and specific with your notation. Let me erase that because that's actually no bueno. And let's try again. So we've got 5e to the a plus 3 equals negative 39. So remember, e is an actual number, and we undo it with a natural log. So to get e to the a plus 3 by itself, the first thing I need to do is actually divide by this 5. Oops, positive 5. So we get e a plus 3 equals negative 39 divided by 5. I don't know. Let me get my calculadora. Sorry. Here we go. So negative 39 divided, oops. Negative 39 divided by 5. Okay, negative 7.8. Great. All right, to undo e, we'll actually do a natural log, ln, and whatever we do to one side, we have to do the other. So this and our e, those are the same base, they cancel out, and I get a plus 3 equals natural log of negative 7.8. So here's the issue. Can I take the natural log of a negative number? No, we can't, right? Whatever is inside of a log has to be a positive value. So we get to this spot, we realize that this problem is no longer possible. Our answer is no solution. Let me put a box around that sucker and a box around that. The end. Okay, moving on to number 3. 3 times 5 to the x plus 9 equals 44. First thing we're going to do is divide both sides by 3. I got to get this base by itself. Those go away. 5 to the x plus 9 equals 44 over 3. That isn't going to simplify and be a nice number. I'm actually just going to leave it as a fraction because fractions are better anyways. So I've got this exponential base of a 5. I have to undo my exponent. And I know to undo an exponent, we have to use a log. Remember that my bases need to match. If this exponential base is a 5, then my log base needs to be a 5 as well. Whatever we do to one side, we have to do the other. And I always just kind of write it awkwardly, like on an angle, and then add my parentheses in. Those are going to cancel, and we get x plus 9 equals log base 5 of 44 over 3. Last step to get x by itself is that we're going to subtract 9. And again, here's why we use our parentheses. Log base 5 of 44 over 3. then we're subtracting 9. Remember, our order matters. I am not taking the log base 5 of 44 over 3 minus 9. That minus 9 is separate from our log. So use parentheses to make sure you keep it nice and clean and neat. Okay, for this next one, I see that I've got x's on both sides of my equation. So looking at it though, I also notice that both sides are being taken to the same log base. So instead of trying to move things around, I'm just gonna get rid of that log base immediately. So it's a base 20. I can undo this log base 20 by saying 20 to the power, right? And that means these bases cancel and this comes down. So I get negative 3x minus 2. I have to do the same thing on the other side, 20 to this power. Hey, same bases, they're gonna cancel out. And I just get negative 4x minus 6. Well, now this is a basic algebra 1 problem. Let's get all my x's on one side, all the numbers on the other. We'll add 4x, and then we'll add 2. So I get positive 1x equals negative 6 plus 2 is negative 4. Awesome. So I know what x equals. The last thing that we need to do for this problem, because I start off with logs, is double check that negative 4 will not make these values less than 0. So negative 3, double checking, negative 3 times negative 4 minus 2 equals negative 3 times negative 4, it would be positive 12. Minus 2 is 10. Check. The next one, negative 4 times negative 4 minus 6. 4 times 4 is 16. Negative times a negative is a positive. So that's positive 16 minus 6 gives me positive 10. We're good to go. If your problem starts off with a log, make sure that whatever you get for x does not make whatever goes inside of the log a negative value. Okay, moving on to number 5. There we go. Okay, so log base 3 of x minus 2 minus log base 3 of 2 equals 3. So I see I've got two, I'm taking the log of two different things, but they have the same base. So I'm going to take a second and I'm just going to condense that in using our properties of logs. If I have subtraction, I know it becomes division. So I'm going to keep this log base 3, and it's going to be x minus 2 all divided by 2. And then I just left that side alone. Now that this is nice and simplified, I've only got this one log, I can easily undo it using exponents. So my log base is 3. I needed to use 3 to the power of to undo it. And whatever I do to one side, I got to do the other. That goes away. And so we get x minus 2 over 2 equals 3 cubed. 3 times 3 is 9, and then 9 times 3 is 27. There we go. Now it's basic algebra. We'll multiply both sides by 2. So we get x minus 2 equals 27 times 2 is 54. And then we're going to add 2 to both sides. Easy peasy. There's my answer, but let's double check, because again, I had a log at the beginning. 56 minus 2 is 54. That's a positive number. We're good to go. We don't need to worry about our domain. Okay. Ooh. So this one's good. Okay, so I see that we've got 2 components that have x in it that I am taking the log base 7 of, and then I've got log base 7 over here as well. I don't want to move this over because it doesn't have any variables, right? Remember, I'm trying to isolate the variable, so everything else needs to move over. Just leave that there. I will, however, combine both of these pieces because they both are a log base 7 and they both have an x in it. So we are adding, which really means that we are doing multiplication. So this is log base 7 of x plus 40 times x. And that equals log base 7 of 41. Okay, we'll undo this log base 7 by using our exponents. 7th power, here we go. Times x equals 41. So this is a little tricky, right? So let's distribute this first. So we've got x squared plus 40x equals 41. I see an x squared. Our first thought should be get everything over to equal 0, so we can factor it out into our 2 sets of parentheses. Cool. 2 sets of parentheses now. I know I've got x. This is positive and this is negative, so one of these needs to be positive, one of them needs to be negative. And we need to think about what are our factors of 41. Well, the first one I can think of is 1 and 41. I'm sorry. Hey, wait, look at this. If this is a 41 and then this is a 1, 41 times negative 1 is negative 41. 41 minus 1 is 40. We are good to go. So that means that x can either equal negative 41 or positive 1. Go back, and we need to double check both of our answers. If x equals negative 41, negative 41 plus 40 is a negative number. That's going to be an extraneous solution. Extraneous. Doesn't work. Not a solution. Double check 1. 1 plus 40 is 41. Okay, that's a positive number. That works. And then just regular old 1. Perfect. So that means that this positive 1 is our only solution for that problem. And that's it. Easy peasy. So that is going to be it for today's lesson. I'm going to post a bunch of practice problems for you guys. Work through them, mark any ones that you have questions about, and I look forward to seeing you in office hours. Love you lots. Bye.